Hello YouTubers. Now in this video I'll be covering the example of NTPClient from files, examples into ESP8266WiFi into NTPClient. Okay, so watching this full video, you will come to know that how this mobile devices, the laptops and PC synchronizes the accurate time from the server. Yeah, they uses this NTP, which is Network Time Protocol, for this time synchronization. So you also come to know how to implement this NTPClient logic or client code into the ESP8266WiFi module and synchronizes the accurate time from the server. Then you will also come to know the basic difference between the TCP and UDP. Both are the methods for the data transfer over internet. And then you'll also come to know the what's the difference between the NTP time and Unix time. So all the things you'll come to know by watching this full video. So let's get started. Okay, so in this code there are two necessary declaration of this library. Okay, before that let me tell you one thing. If you want to know in detail about what is this NTP protocol, who invented this, how this works and everything, you will come to know by reading out this wiki page whose link is attached in this code. So you can go ahead and read out this wiki page to know everything about this NTP protocol. So starting with the code, let's jump to my edited version of this code rather than this. That will be here, I think. Yeah, this is the edited version of the code. So let's get started with this code. First of all, the two necessary declaration of library, ESP8266WiFi.h and the Wi-Fi UDP.h. So here we are using the UDP method for data transfer. So this library is mandatory for that, using that method, the UDP method. Yeah, yes. So starting with the SSID name and password, which is you all must be knowing now. You need to enter your router's name and password to give access to ESP8266 to talk to the internet. Then here it is declared as one local port called 2390. Now in this particular video, genuinely I am saying that I have two doubts which are not cleared. Even I googled about this doubts, but didn't got this proper answer. So in case any one of you watching this video knows the solution or the answer of my doubts, do let me know in the comment below. That will increase my knowledge. But yeah, I will tell you what I understood by reading this code, by uploading, by experiencing the working of this code. So this local port which is declared 2390. Okay, so first of all, this is a local port, so it is not mandatory to use this particular 2390. You can go for any of the number, like 5555, 8080, anything, any port you can use here, because this is a local port. So what I think, or what I understand by this local port is, this port will be created from ESP8266 and your router for data transfer method. Here it is written as local port to listen UDP packets. So there may be something that the receiving port is different and transmission port is different, because when I googled, I need to open this Google Chrome. When I googled about TCP UDP port numbers, I found that the port used for this NTP protocol, for network time protocol, is 123. So I'll just type NTP. Okay, as you can see that the port used is 123 for network time protocol. So this is a port, and this is also mentioned inside the code. I will just let you know. If you scroll down the code on the last third line, yeah, as you can see that the UDP.begin packet, the address which is server address, and the port here used is 123, which is the default port for the NTP protocol. So that is the port for data transmission, and what I think this can be the port for listening the UDP packets, as it is written here, from the router to our ESP8266 board. But this may not be the answer. But what I understood by this code is that what I said. If I'm wrong and you know what this local port means, or what this local port means, then do let me know in the comments. Then moving ahead on the code, we have IP address class with an instance called time server IP. Now here one thing you need to take care is that, so as you can see, the above line is same as the below, just the difference is they have defined a particular numbers or a digit, or you can even say that a particular IP address of the server. Now in NTP, first of all, let's visit that website that make you much clear that what I'm trying to tell you. Okay, so this is the site from which we gonna fetch the data of the accurate time. So as you can see that this site contains several servers. The IP address is mentioned here, and the location of the server is also mentioned here. There are several servers which contains the information of the time. Now I don't remember exactly, but somewhere I have read that in NTP protocol, or in the this client which are installed in the mobile phone, in the laptops, and any embedded system, what they do, they don't prefer, or they don't rely on any single server to get the information of time. Rather what they do, they go to the website, choose a random server and take the data from them. So again, every time it will go to that website and it will choose the random or different server than the before. Now why? The reason they mentioned was that they mentioned the reason is if we depend on single server, then we may find difficulty in the accuracy of the data received. So as you can see that here the status of the servers is written as all servers are okay and busy, while here it is all servers are available, while some servers will be all servers are busy. So what happens if we rely, okay, so take the example of this server. If we rely on this server particularly, then if and we are trying to fetch data from this server, as you can see that all servers are busy at the particular time, because it maybe for any reason. For example, there may be a number of requests at the particular moment which a server was not able to handle. So the reason can be anything, but we can't rely on the single server. Rather, if we choose a random server, then we can choose a time randomly from different servers. So if we are on the one server and that is busy, it doesn't matter. On the next time we'll move on to the next server and fetch the time from that server. So in short, this is the reason why they depend on a random server rather than a particular server. So this is what done here on our ESP code. If we uncomment the first line, then this line will choose this particular server address for getting the time information. And if we just comment this line and write this line written below, so here it is written as time server IP. Here none of the IP address is mentioned particularly. So this line will choose the server randomly. I have written here in the comment. This will pick up a random IP server from the website time.nis.gov, while this will pick up the server with the address 192.6.15.28 from the website this. So this is the reason of the why this line is written here. Okay, so after that there are two variables declared. One is the NTP underscore packet underscore size, and another is packet buffer. So first is the size of the data received and transmitted. So here is my second doubt. The first doubt was of local, but the second doubt is this. Now what I know is NTPClient uses 48 bytes of information or data to be sent to the server, and 48 bytes are received from the server. Now this 48 bytes of data contains particular information in particular bytes, like 0 byte contains this information, 5th byte contains this information, maybe 12th byte contain our data, maybe 40th byte contain our data, and other are rest of the information is given. So what is my doubt is I didn't find the particular sequence that which byte contains which information. That particular sequence I was unable to find on the internet. But if you know the particular sequence of data transmission and reception in NTP protocol, then do let me know in the comment. But the thing I know is that there is 48 bytes of data transfer. So here the size is declared as 48 bytes, and the below a packet buffer is created whose size is also initialized with 48, which is NTP packet size. So after that again UDP instance is declared from Wi-Fi UDP class, so which we will be using further in this code. So after that the setup begins with serial.begin 11.5.00 default baud rate of our ESP8266, then to blank line. After that connecting to your SSID, which with a function called Wi-Fi.connect, which takes two parameters, SSID name and password. This will connect to your router, and as soon as it gets connected, it will change the status of Wi-Fi.status function to WL_connected. So we are just polling this function to get this string or this status of a WL_connected. If we are getting a status other than this, then we're gonna wait in this while loop forever. So as soon as it gets connected, the status will be changed to this, and this code will jump out of this loop. So it will show Wi-Fi connected, and IP address will be printed. The local IP address will be printed by the function called Wi-Fi.localIP. This is a nice little function which will print out our local IP address assigned to our ESP8266 board. After that, starting the UDP. As we begin the connection of our serial port, we need to begin the communication for data transfer in UDP method also. So with the function UDP.begin at local port, we can initialize, or we can begin our connection. After that, it will print out the local port by this function UDP.local port, and the local port will be same as the defined above, which is 2390. Then moving on to the loop, here the main role will be started. Until now, what we first created an IP server with which assigned to random IP. Then we established a serial communication and default baud rate. We established a UDP communication at the local port, which is 2390, and now we are utilizing this connection. So first of all, with the function Wi-Fi.host by name NTP server name comma server IP. So this is basically the name of the website comma the IP address from which we need to fetch the data. So this is the format which in which it takes the input. So this function will go to the website, and according to the IP address mentioned, it will be getting the data from that IP address. Now here the time server IP, as you all know, we have left it to take random IP address value. So we haven't declared any particular IP address. So this will take the random IP address value, as it is written on the comment also, get a random server from the pool. Pool of the server, choose a random server. Okay, so moving ahead, here we have created a local function called send NTP packet, which takes the input again the random time server IP. Now what this function does, let's see. Here is the function with send NTP packets, which takes the input of IP address, which is again random. Serial print line and sending NTP packets. Here function called memset is used. Now memset function stands for memory setting. So what this function will do, this function will set particular data in the particular variables. So what this line will do in this code, this line will assign the packet buffer variable which contains the 48 bytes information with this 0 value. So all the 48 bytes in the packet buffer will be assigned to value 0. So this is what this line is doing, which is memory setting. So after that, they are assigning particular value at particular location or particular bytes, which, as I said, I don't know which location reveals what particular function. So I don't know the format in which the data is transferred, but yeah, what I can say is that they are just arranging the particular data in the particular bytes, and some of the bytes, the information about some of the bytes is written here in the comment, just like in the 0th byte it is for LI version or mode, 2nd byte is for stratum or type of the clock, so on. So there are different functions for different bytes. Okay, so after assigning all the values in the buffers, we are sending through UDP. Now this method of transmission through UDP is same as that in the what we did in Wi-Fi client. So you can watch the video of my Wi-Fi client. What we do in this client, that first of all we create a connection at a particular website with a particular port by client.connect function. This is similar here, udp.begin packet, the website address, and the port at which we need to establish the connection. So address will be random, which is IP address, and the port is 123, which is default port for NTP communication. After that we will write the data to that website. Okay, so first of all we need to transfer the data to the server, which contains all our requirements, that like with this data we want from this server, from this clock, and this version, this mode. Okay, so all this information which contains our requirement is sent to the server. The server, according to our requirement, will send back the response. So after sending the data, we need to end this connection by udp.end packet. So this is a function, is just for sending the data to the server, and as its name reveals the same, send NTP packet. After the relay of 1 second, we are waiting for the response from the server. Now what this parse packet function will do, udp.parse packet function. Now this function will return the number of characters we got in response. I have written in this comment, this function will return the number of characters we got in response. In short, the length of the string received from the server. Okay, so this function will return an integer value which are stored here in the variable called CB. So if CB is 0, we will be printing as no packet yet received, and if it is non-zero, we will be printing as packet received, and whose length is equal to CB, which is nothing but the parse packet. Okay, so after that we are reading the data which with a function called udp.read. So we need to give the parameters of where to store and what size. So two parameters we need to add. So we need to store in the packet buffer, and the size is NTP packet underscore size. So with this function we are reading the data. Now here I need to tell that what's the basic difference between TCP and UDP. So there are many differences, but particularly for this example I will be telling you only one or two differences. So first of all, TCP and UDP both are methods used for data transfer over the internet. TCP is regarded as a reliable method for data transfer, because in TCP we have several error control bits, we have acknowledgement procedure, that data is sent, we are waiting for the acknowledgement and then we'll send another data. So there are some methods in TCP protocol which makes the communication reliable, while in UDP is a totally non-reliable communication. There are no such thing like error control bits and acknowledgement, something like that. So why it is used, why UDP is used? So UDP is much faster than this TCP protocol, because the data which is to be sent is very less as compared to TCP protocol. Okay, so in the condition where data transfer speed is more important as compared to data accuracy, then we'll go for UDP communication or UDP protocol. And in the condition where we require the data accuracy more than the data transfer speed, then we'll go for the TCP communication protocol. So here we are going for UDP, because we want the as quick response as possible from the server, and if the data is not received at a particular time or at a particular request, no worry, we can ask for another server, or we can just send another request for getting the data. And so we have choose the UDP packet for faster data transmission. So moving ahead, we have, okay, so here they have written 2 lines of command. This is important. So as you all know that the received data is 48 bytes long. Now which byte contains the information, which required information, that is the time. So here it is written that the byte 40 and its consecutive 3 bytes, which is 40, 41, 42 and 43, this all 4 bytes contains the time information. So first we have collected the data from 40 and 41, then saved into a high word variable, and from 42 and 43 we have stored into the low word variables. And by combining all these 2 words, we have created a unsigned long integer value and named it as seconds since 1900. Now here you will come to know what is NTP time and what is Unix time. So NTP time is the time in seconds from January 1, 1900, as it is written in the comment that this is NTP time, which is seconds since January 1, 1900. Now first we need to convert it into Unix time, because we are using in day-to-day life the Unix time. Now what is Unix time? The Unix time is a time in seconds from January 1, 1970. So difference between NTP time and Unix time is of 70 years. So we have a 70 years difference between the NTP time and the Unix time. So we need to apply some max to convert NTP into Unix time. So here we need to subtract the 70 years, and the 70 years times in seconds is calculated. Okay, so here I have shown that how I calculated the time in seconds for 70 years. So after calculating this time, I have subtracted from the time since 1900. So I got in response as epoch, which is nothing but the Unix time. Now Unix time is a time for GMT 00, which is in the green, which is written here as Greenwich Meridian time, which is in London. So this is a time for London. Now we need to convert this time into the time according to our location. Just for example, for India we need to add 5 hours and 30 minutes to get accurate time of India, because India it has location of GMT plus 530. So according to your location, you need to find the GMT plus or minus something, and you need to add into hours and into minutes to get the accurate time. So here with some mathematical functions, we have converted seconds into the hours, minute and second of the particular day. So all the things I have written in the comments, so you need not to think that how or what this logic is doing or what this max functions is doing. So everything I have mentioned in the comments, so you can just read it out and got to know that what is happening behind the scenes. Okay, so just by applying some mathematics, we got the time in GMT 00, the time for the London, the accurate time. So just upload this code and let's see what we get in response on the serial monitor. Okay, let's just open the serial monitor. Okay, so we got the UTC time or GMT time as 12:06:12. So let cross check from Google. So time at GMT 00. Okay, rather than we just type as time at London. So it is 12:06. So this is the accurate time we received here, which is 12:06. Okay, so this code fetches the accurate time from the website time.nhs.gov from the different servers but at different time. Okay, so I hope you got basic idea about how this devices fetches the accurate time, from which server they are doing and from which protocol they are doing this. So you can use this code wherever you require to sync your code with a particular time, with the accurate time. So you need not to depend on the hardware components, other than you can depend upon the accurate servers over the air or on the cloud for your time data. So this is it about this video, and yeah, do let me know about the doubts which I have in this code. If you know, then let me know in the comments below. Okay, this is it about this video, and subscribe my channel if you haven't for next videos upcoming for this series. Till then, explore, learn, share with me, techiesms.